For the last 60 years, Paducah, Kentucky has been the point of origin for enriched uranium bound for U.S. energy and defense. 10 miles west of Paducah and 3 miles south of the Ohio River, the Paducah Gaseous Diffusion Plant is still active, but its process is antiquated, and the plant will likely close within 10 years.
DOE has a huge footprint here, over 3,000 acres. It's very expensive to maintain, tens of millions of dollars a year just to have personnel there. Paducah's a city of 25,000 people. They had a workforce down here over the last 30 to 40 years that's been anywhere between 1,500 and 6,000 people, depending on what was going on. So if you look at that relative to per capita in Paducah and McCracken County, huge economic impact historically. And for Paducah to move forward, they're going to need to replace that economic opportunity that this facility has provided.
Before Paducah can move forward, its nuclear legacy must be dealt with. The plant and the surrounding 3,000 acres is one of the most contaminated top-secret sites in the United States. In 1988, technetium-99, a radioactive metal, was found in the groundwater.
That kicked in a whole set of federal regulations that ultimately ended up putting the Paducah site on something called the National Priority List of Superfund sites.
Technetium and TCE, a chemical used to clean equipment, make up 5 miles of toxic underground plumes.
We've put in pump and treat systems on both of the plumes that head towards the Ohio River, and they're there to contain the groundwater contamination. That being said, it still take well over 100 years in the best scenarios for this groundwater to come back to its natural chemical state.
2001 to 2003, there were some very contentious issues that were starting to develop surrounding Paducah.
That communication issue between the site, DOE, the site contractors, the local community, as well as government officials, is extremely important in this case because quite bluntly, there's a trust issue between the public and those operating the site. They, to some extent, feel like the site's being pulled and they're being left with something they're going to have to deal with forever.
The objective of the center was to try to bring in scientists that could address very complicated technical issues with regard to the contamination and try to bring sort of neutral, sound science to the issues.
Since 2003, the Kentucky Research Consortium for Energy and the Environment has gathered scientific data, investigated remediation techniques, and talked to Paducah residents about the future of the site.
But what we were seeing for the last 20 years was just one iteration and another of the same thing. It was all very prepackaged thinking with prepackaged outcomes, and it wasn't really thinking on the scale of what was really necessary economically to, help Paducah move forward into the future.
What was missing was a way to communicate the science of what was happening underground to spark conversation about the potential of the site. That's where design came in, and why Rodney Andrews presented the problem to Gary Rohrbacher.
He said, there's this situation out in Paducah, there's a toxic plume, there's the imminent closure of the plant. Is that something you'd be interested in? So I said, absolutely. He said that no proposal would be complete if we didn't consider the replacement or regeneration of the 3,000 or so jobs that would be lost at the closure of the plant.
That was kind of the origin, was talking with Gary and looking at, could we do this with design students as a way of looking at ideas that maybe no one had thought to look at. They came up with very creative, very well thought out options.
We looked at the history, demographics of the city, the economy that would lead up to where they are today.
You have what were once the world's largest buildings now available for use. Being on the river, one of the ones that I thought was quite interesting was becoming a recycling center where things that are more difficult to recycle that are normally not done locally could be barged. The other one that was looking at building this as a hub for high-speed rail because it sits between Chicago and Atlanta. It used to be a major rail center.
But of all the future uses the students imagined, the one with the greatest potential was the idea that the problem, the contamination, was the solution.
We were hoping that looking at the things that the site has to offer right now, including the contamination underground, Paducah could actually use that as an asset.
If there was a kind of research center and we actually used the plume as a test subject, and then we built the labs and the facilities necessary to clean it up on site, that investment would be just that. It would be an investment because we could sell that technology or export that technology all over the United States and then all over the world.
UK is testing new remediation techniques like nanoparticles to break down TCE and algae to capture and concentrate technesium. But how will we know if these techniques have changed the plumes?
The plume is underground, right? It's out of sight, out of mind.
In the beginning, it really was. It was just a bunch of data and numbers.
We were able to plug in those data points and actually make that plume tangible.
We were able to give the plume a form and show it visually as it's changed over time.
And the idea was that the Citizens Advisory Board offices out in Paducah, they could have the 2005, 2008, and the 2012 plume, and the citizens could see the effects of remediation techniques.
We were trying to get it at a scale that was usable for people to understand what was actually on the site. We wanted layers of information to be included for the scientists that they could literally change out if they needed to.
We decided to use plexiglass and print on them because it's a readily adaptable technique.
All of the pieces can be rapidly remade and inserted into the model. There's no glue, no screws, everything is removable.
So we built a toolkit of different kinds of pieces, everything from wax pencils that you could write on the models, to markers, to measuring tools.
Things can be wiped clean, everything can be lit from underneath. It's very visual, very almost charming in a way too, so it's exciting to stand around and talk about it.
You have just a whole assortment of people that have a stake in what's going on underground in Paducah, Kentucky. And you give them this great tool where they can start to interact. They can imagine alternative futures.
By being able to look at the ground surface, the infrastructure, the buildings that we've put there, and all the natural attributes of the area, kind of ties everything together and lets someone understand all the relationships that are being dealt with.
The work they've done has really brought much more public attention to the work we are doing.
It was exhibited at an International Architecture Biennale in Rotterdam, the Netherlands. The title was Making City. The topic was to try to understand new ways that institutions are working to create public-private partnerships to take on wicked, difficult problems.
And so these really have been very good tools to explain to the public, here are the assets and here's what these may be able to be turned into over the next several decades to be a positive gain for the Paducah community rather than just seen as a loss.
It's awesome to see seasoned Department of Energy official or an agency official or somebody who works at the plant amazed by what a 20-year-old graduate student can do. And I think that gives them confidence, and they start to see how designers could contribute to larger issues.
This project has made it very clear that design has a role to play with an agency like the Department of Energy, with an agency at our university and research arm like the Center for Applied Energy Research, that it might not have had.
The University of Kentucky's expertise in design, energy, and environmental cleanup has given the Department of Energy and the people of Paducah a new way to visualize the future.